The part of the maxilla that bears the teeth is called the alveolar process. We'll look at the teeth later in this section. The alveolar process ends behind at the tuber. Now we'll bring the mandible into the picture. The mandible develops from two originally separate bones, one on each side, which fuse together here at the symphysis. The mandible is described as consisting of the body and the right and left ramus. The corner between the ramus and the body is the angle of the mandible. The rounded projection that articulates with the temporal bone is the condyle, or condylar process. The narrowing below the condyle is the neck. The sharp, slender projection in front of the condyle is the coronoid process, a major muscle attachment, as we'll see. The dip between the coronoid process and the condyle is the mandibular notch. The angle of the mandible is roughened on the outside and on the inside by the insertions of a matching pair of muscles, the medial pterygoid on the inside and the masseter on the outside, which we'll see shortly. The body of the mandible is described as consisting of the base and the alveolar process. The side of the body slopes upward and inward, slightly on the outer aspect, markedly on the inner aspect. The posterior part of the alveolar process bulges medially above this hollow, the submandibular fossa. This projection in the midline is the mental protuberance. On the inside, this roughened area is the mental spine. Two pairs of muscles are attached here, the geniohyoid and genioglossus muscles. On the inner aspect of the mandible, this thickening below the coronoid process is the buttress. In the middle of the ramus, level with the tops of the teeth, is the mandibular foramen. Just in front of it is a small upward projection, the lingula. The mandibular foramen is the start of a tunnel for the inferior alveolar nerve and blood vessels. A major branch of the nerve emerges on the outside at the mental foramen. Now that we've seen the mandible, let's take a look at the joint that enables it to move, the temporomandibular joint. It's a synovial joint with articular cartilage on the bone surfaces and a joint capsule that encloses synovial fluid. It's a double joint. There are two separate synovial cavities, one above the other. These are separated by an articular disc that's flexible and highly movable. This arrangement permits two kinds of movement, as we'll see. Here's what the two joint surfaces look like in the living body. They're shaped quite differently. The articular surface of the condyle is curved sharply from front to back. It's almost pointed on the top. The articular surface of the temporal bone has a double curve. This concave part is the mandibular fossa. This convex part is formed by the downward bulge of the articular tubercle. Here's the temporomandibular joint with its joint capsule intact. Most of the capsule is thin and loose to allow the various movements that we'll see. On the lateral aspect, the capsule is thickened by this lateral ligament. The articular disc is inside the joint, here. To see it, we'll remove part of the capsule above and below it. Here's the upper joint cavity, here's the lower one. Here between them is the articular disc. It's made of dense fibrous tissue. It's attached to the joint capsule all the way round its edge. Here's the articular disc by itself. It's thin in front and thick behind. It's quite flexible. The two kinds of movement that can occur at the temporomandibular joint are a hinging movement and a forward and backward gliding movement. The hinging movement takes place between the condyle and the disc. The backward and forward movement takes place mainly between the disc and the temporal surface. The normal opening and closing of the jaw is a combination of the two movements. If you put your finger here, you can feel the condyle moving forwards as the jaw opens.